Welcome back, everyone, and this is going to be the first video about using our new fungi engine to make some videos. So to start off with, I want to make a planet, and it's going to be a simple planet. It's not going to be something we can get to walk around on, but it's just something simple that to illustrate how to do bump mapping. And if you look online, bump mapping is done traditionally, normally using normal maps. The idea of what a bump map is, to bump map is to create an illusion of death. So this way you can make things look like they have some kind of texture. There's, certain things are brighter, certain things are darker. It kind of has like it's a play on light and shadows. It makes things look more 3D-ish than being very flat. And I saw this tutorial on how to use 3GS to quickly make a planet, and it's really neat how it looks. To me, it looks beautiful, and it's because it uses bump mapping, has really great textures. But in this video, uses in this tutorial, he just uses 3JS, so it's actually really quick and easy to kind of implement. Because all you just use the shaders that exist in 3JS, and you're done. It's pretty simple. In today's video, we're actually going to write the shader from scratch, and we're going to deal with bump mappings, not with normal maps, but with actual height maps. Because, like I said, this one is a good example because it doesn't come with normal maps. The Earth comes with a bump map instead. So you have to treat bump maps differently than you do with normal maps. And I'll do a video in the future about using normal maps, but for now we're going to do with bump maps. And the textures comes from this site. It comes with a bunch of great stuff. It's really amazing. But like I said, Earth comes with a bump map instead of normal maps, but it comes with every planet. Like you can make Mars, you can make Jupiter. The normal map video, I'm probably going to use Mars because it has a normal map. So it'd be a great example. But yeah, this site has all the textures you need to create these planets, which is really neat. And to get an idea of the difference between a bump map and a normal map, here's the site. Here's something that can take a height map and turn it into a normal map. And like I said, it creates an illusion of depth. Because if I were to change some of these values, then it no longer looks. It looks more flat than before. If I add some strength to it, it starts creating more depth. But it's just an illusion. It's just all an illusion. It's just a play on light and shadow, light and darkness. And bump maps are set up in a way that zero height is at 50% gray. And if you go above the gray color toward white, you're going to create height. If you're going to go from gray to black, you're going to create basically subterranean type of space. So if you're kind of creating a planet, the level ground will be gray. Under the ocean will be in a black area, and the mountains will be in a white area. So if you're looking at like this, that's the idea of what a height map is used for. So we're going to actually take the height map information and convert it into normal information that we can then use to create lighting, the lighting effect. So we're going to look at some source code. So we're going to start off with our simple new template, and we're going to load in our 3 textures. And there's an earth light texture, which I'm going to show you at the very end. It's not in the text tutorial that I saw, but the site, if I go to earth, has a night lights texture. So we're going to play with that at the very end for fun. So you get a little extra other than that text tutorial. So to build the Earth is very simple. We just have UV, and we kind of just scale it up a little bit, move it around, set a certain degree, whatever, and then we're gonna just rotate it. And we have our shader, and it's an updated version of the shader I've been using for Fung lighting in the past. I just took away a lot of constants and made them into uniform, so we can use the same shader, make different materials for different planets, because different planets might need different settings to make them look better. In our vertex shader, very bare bones, very simple, we're going to push a bunch of information to our fragment shader. So we're going to pass our UV, we're going to pass in our world, we're going to rotate our normal, along with the position and rotation, not the position, the rotation of the vertices. So this way lighting can stay. And we're going to pass in the unit direction from the vertice to the light and from the vertex to the camera, because we need that to help create lighting, to control the lighting a lot better. And it's important to rotate your normals, because if you don't rotate your normals, this is what our planet looks like. And there's a light source right here, and you can see as the planet rotates around, the light source always stays the same. If you don't rotate your normals along with the vertices, you'll see that the lights, even though the light source is here and it's static, the light itself moves, because the light is the calculation is, if you don't transform it, it ends up doing all the lighting on normal space while the vertices exist in world space. So just keep that in mind, is that when you do this, you have to make sure your normals are rotating along with your vertices, else the lighting will kind of look really funky. Like the lighting will move away from where the light is. So that's that. And we're creating everything here because this way we can take away these two subtraction operations, which ends up being 6 operations because it's X, Y, Z. From the fragment shader, because the fragment shader we do for every pixel, and in the vertex we do it for every vertex. So we do less math overall by pushing more things into our vertex instead of doing it in a fragment shader. Now, the one thing we have to deal with is that when we come to the fragment shader, all these values have to be renormalized again. Simply because when we put them as vertices, they're normalized, but then in between the triangles, they get interpolated. And when they're interpolated, the values change to the point that they're no longer normalized. So even though those are the correct normals for that specific pixel, they're not normalized. And to do dot product operations to make the math like flow really easily, to kind of create a range between -1 and 1, all these unit vectors have to be normalized. We can skip this for now because that's bump mapping, and this is just our regular. This is our Fung lighting. That's it. Just 6 lines of code. I'm not calculating different colors for each lighting. I'm just combining all the values, multiplied by a single light color, and basically multiplying to our base color, which is our texture. So this shader, as it is now, creates this. Now, the only problem with Fung lighting they have is that I want to see more of the Earth. So we need to change the Earth a little bit. We need to change how the diffuse lighting is working. So that's going to be like the first order of business before we can do bump mapping. But we need to fix the lighting so we can see more of the Earth, so we can do more bumping. So we can see the bump map a lot more than just that tiny little spot where the lighting exists. So instead of clamping the values between 0 and 1, dot product gives us a value between 1 and -1. If it's a value of 1, these two normal directions are pointing exactly in the same direction. So that means the normal of that pixel is pointing directly at the light. So that means that pixel should get the maximum amount of light. If we get a dot product of -1, we get a value of is the opposite side. So it's completely looking away from the light source. At that point, we want to draw everything as pitch black. So we're going to do a little bit of math, and we're going to convert everything from -1 to 1 to 0 and 1. So this way we can kind of control the lighting a lot better, because when we're dealing with colors, colors don't exist in the negative zone. So we need to convert everything, kind of remap everything into non-negatives, and then to control it. So where black exists right here at 0. At 0, like I said, 1 is pure color, 0 is like no light, negative is absolutely no light. Darkness begins at 0.5. It's the halfway point, so we're reshifting everything. So the idea is that here is going to be 1, and over here in the dark side of the planet is going to be 0. So this way, it's a lot easier to control the range of how much lighting is. So now that I have this in a range that's easier to manipulate, for the diffuse color, I just say between 1 and 5, do a transition. Anything less than 1 is pure black. Anything over 0.5 is pure white. So that transition, and the value we're going to pass in is the angle that we calculated times the strength. So we can actually choose how strong we want the diffuse lighting to be. And I think by default I have it set up as 1. Right? Yep, diffuse lighting as 1. I want the 1 to be a maximum. So with that, I put it into diffuse, and I put diffuse into diffuse bump because I'm not ready for bump mapping yet. And we'll click refresh. And now you can see that we can see a lot more of the planet, because between here and here is between 0.1 and 0.5. So this is where the grayscaling happens. And then after everything after that, we get lighting. So this way we can actually see more of the planet when we do bump mapping. Okay, so like I said, we're changing the Fung lighting model so we can actually spread the light. We can scatter the light a little bit more around the planet. Now comes bump mapping. Now I can't give you too much information on bump mapping because there's very little information about how to do it with height maps, and because of that, I had a hard time finding how to do it. Since I noticed in this article, he just threw it into the shader from 3JS. That means 3JS can handle bump mapping with height maps. So I was like, man, well, I can't find any information with the math or how to really do it, because every time I search for bump mapping, especially with just height maps, there's just people asking for questions, how you do it, or everyone's just talking about normal maps. Or they just say, take your height map and convert it into a normal map and just use it as a normal map. So that's what normally people want to do. But I want to do things the hard way. And especially since that tutorial uses bump maps with height maps, God damn it, I want to do it with height maps too. So since I know 3GS can do it, I cheated. I cheated. I went to 3JS because I'm shameless, and I was like, well, how do you do this? And when I went to it, I came to this amazing example of this source code comes from Unreal Engine. I was like, oh, okay, so I'm not the only person who had problems finding this information out. Okay, good. I don't feel so bad finding this information. If you look in the PDF file, pretty much all this code is in that PDF file, which Unreal Engine, I guess, wrote out a document how to do it. There might have been some small changes done. I don't know if these guys did it. Maybe they did. I don't know. But like I said, it's hard to find information how to do this, like in a shader code. So 3.js does it because they copied off Unreal Engine. So I don't feel bad. I'm stealing from someone. You know what? Here's the thing. I'm stealing from someone who borrowed. How about that? I'm stealing from someone who borrowed. So I'm more wrong, but I'm admitting to it. I'm going to admit that I'm stealing their code. And I try to read the document. I'm not a mathematician, but the whole idea is that I'll give you the high-level idea behind how to convert a bump map, height map to a normal map. The idea is that you end up calculating the normal direction, right? And I think to get the normal direction, you have to figure out tangent and the binormal. And those three values, the normal, the tangent, the binormal, they are essentially the up, forward, and right direction. In the previous videos, when we deal with direction, everything exists in the transformation matrix. So when you do the rotation and the translation and scaling, that creates a transformation matrix, and within the transformation matrix is the actual left, right, up, forward, and right direction. For me, WebGL seems to go to the left, not to the right. So all my code says left. So I'll just say left then. But I think it's supposed to be right. But code-wise, to me, when I look at things, everything looks like it's going toward the left side. So the left, the up, and the forward. So this math basically essentially does all that to get the up direction, which is pointing, it becomes the normal direction of, which does the normal direction. And it does that by grabbing the pixel that you're accessing, and then it grabs a neighboring pixels. So essentially, like this comes up, this might become left, and this might become forward. I'm not exactly sure, but it kind of helps create those directions. And then once you have, like, I guess once you have the binormal and the tangent, then you can kind of calculate the actual normal value. I think that's what this is actually doing, because at the very end I get the normal value. So this everything up to like the very end, the surface normal ends up calculating. If I remember correctly, calculates those. It creates the tangent and the binormal first. Like I said, it creates basically the forward direction and let's see, the forward direction and the left direction. So you have which makes sense because you think about x and y, the up and down. So it's kind of a 2D thing. So you calculate up, you calculate left or forward and left, and then the only thing, then when you do like a cross product, does this do a cross product? Yeah, it does cross products in here. When you do a cross product, it gets the last one, which would be the normal direction that we want. So, like I said, even though I can't explain the math, like all the little tits and bits, that's the overall concept behind how to convert the height maps into normal map information. So, even though I did steal this, I did try to study and understand it. Like I said, I just can't explain why certain things are certain bits. If you go read the PDF, you probably get better understanding of it, especially if you understand math. But that's the high-level concept behind this. So I can just uncomment this and comment this out. So we pass in the text tree we want. We pass in the UV value, or what we want, and a scale. Basically, how strong do we want this lighting to be? Basically, and I have it as a constant for now, but eventually it'll be uniform. That's why I already named it with a U underscore. Eventually I'll just make it a uniform, but for now, just to make it testing, I made it a constant. So this way it kind of creates, like I said, I don't know what this function does, but like I said, it kind of helps create the values to kind of create the tangents and the binormals. And then once you have that information in, you give it the world. You give it the world position, and then you give it the normal that this pixel actually has. So you kind of convert that normal into the new normal, the new up normal, basically. If you ever done the look at rotation function, you always give it the up direction. You figure out the left and right. And then once you have the left and right, you recalculate the up. So I feel like it follows the same idea as the look rotation function. If I go into math, and it would be in matrix 4. Find look. Oop. No, or would it be a quaternion? So yeah, it'd probably be. To me, it feels like it's doing the exact same type of math here. You give it the direction you kind of want, and you give it the up, and it figures out the z, x, y, and then it kind of ends up redoing the new up, which becomes the new normal. So essentially, this code is kind of like a look rotation type of thing. It feels like it's like just looking at the math and getting a high level view of how it works. That's what it feels like how it works. So it looks like a look at function, rotation function. When in the very beginning, I did not understand how this works, but now I kind of do. So this stuff is out now kind of easy for me because after a year and a half, I understand how this works now a lot better. So once you have the new normal number, the new normal, you then create the diffuse value. You get it by having that new normal connecting to that normal, and just putting it there. Now I say I add diffuse to it because I want to keep the lighting. If I don't keep the lighting, let me just click save. So, and that's like I said, everything after this is the same. So once you add the like I'm just adding my diffuse color with my new bump map lighting. So I'm kind of mixing the two lightings together and capping it at 1.1, because if I do it too high, it becomes really bright at the very pole of the light. It kind of makes the bump mapping like flash. It doesn't makes the bump mapping not look good like when the pixels are directly under the light source. So if I click refresh, and there you go. It went from, yeah, whatever. So as you can see now, everything's right. You kind of see it's kind of more flat, but then as it comes in, you start seeing the depth come in. That's because the light source is like right over us. So once you're like a little bit of an angle away from the light source, you start seeing the shadows in the light a lot better, as opposed to being like right under the light source. Everything looks more washed out. So you kind of lose some of that bump mapping. I can get that bump mapping back like here at the light source if I use regular diffuse lighting. If I get rid of this, refresh, now you get this should still be even in direct sunlight, the bump mapping is there. So if you only want to use like Fung lighting, the regular Fung lighting, it works really well. Like but the problem is I can't see most of the planet, which is what I really want to do. So that's why I created that new range, and they created that new that new diffuse lighting. So it kind of washes out the bump mapping a little bit directly under the sun. It kind of I hate that it does that, like right here under the sun. Like the bump mapping is before and after, because like I say, it gets washed out. It completely washes out. But you can kind of like at this point you can kind of see it, and it makes more sense because like if you're noon time, the light's right over you, so you see no shadows. Once you're like the sun or the light source is away, then you see shadows. You can see more shadows, and that is really essentially bump mapping using height maps, and that's all you get. And as added bonus, we're going to add the nighttime texture. So we're going to grab the texture, and we're going to take the fragment color, and we're going to mix the night color with the fragment color by using diffuse. That's why I keep diffuse on top of that, because remember that diffuse is that new gradient I created. And in case you don't, fragment. In case you can't, oh, yeah, whatever. No bother. I was going to just show you the gradient by itself, but I think you kind of see the gradient. Like I said, here's the gradient. Where instead of starting here, it starts more past the halfway point. So there's a nice gradient from black to white being generated using the diffuse lighting. So I'm using that as a way to also mix between one texture and our fully lighted texture, because the nighttime doesn't need lighting at all because it's nighttime. So if I click that and refresh, now if I start rotating over here, this is a great spot right here. You'll start seeing that once these things start entering the darkness, you start seeing the texture mix in, and it's nighttime. It's so you kind of see that nice, beautiful transition between day and night. I think this was kind of a fun thing to do. So on this side of the planet, you can see what it looks like during nighttime when it's not facing the sun. And if you're over here where it's facing the sun, you kind of see where the planet is, and it's like completely lit up, exactly how it probably would look like in space. So that's bit mapping, and us creating a nice planet, like I said, and like I said, I wish I can fix it, but because I want more lighting, it's just hard to mix that lighting in a little bit. If I had probably spent more time on it, I maybe can fix it. But overall, I got a pretty good look. Like I said, I got that nice transition and everything else. So, and it's still got bump mapping when you're not right over the light. Just keep looking at the map like this, and you're golden. Everything looks great. So that's it. For the next video, we're gonna do rim lighting and directional rim lighting. So this way we can kind of make the glow around the globe happen. Like sometimes you see pictures of the planet Earth. There's a slight glow around it. So I'll show you rim lighting, how we apply rim lighting, and then the rim lighting will actually show up in the dark side. Then we'll fix the code where we then do directional rim lighting. So this one, when it's dark, you don't see any lighting of the rim, or the Fresnel. It's sometimes called rim lighting, sometimes called Fresnel lighting. Same thing. It's just lighting it's the way the light shines on the edges of things, kind of like a glossy thing or something. But yeah, there we go. There's our planet. I'm planning to do a couple of videos about dealing with planets. I'm kind of hoping to maybe at some point when I'm done creating all the lighting and everything else, I'm going to have maybe like a little rocket that flies up. You see like a line path that goes to another part of the planet, and then that part of the planet becomes like this round black area. It means that that part of the planet was destroyed. So I'm going to do something simple like that, just kind of just randomly creating a nuclear war on the planet. So that's going to be the end visualization of these tutorials. But like I said, I'm going to build all these little bits and pieces like rim lighting and bump mapping, and we're going to do the clouds. We're going to show how we do clouds and a kind of a parallax effect going. So this way you kind of see the clouds are moving in one direction, the planet rotating in a different direction, and you get that nice parallax effect. And like I said, and at the very end, I'm going to end up just destroying it. Our planet's going to have nuclear war, and we're going to sit there and just watch it slowly become this big black planet. Very simple. So that will be how we end the planet tutorials. But like I said, this will be fun, and we'll see Mars when I decide to play with normal mapping. I don't know if I'll do it during this or wait till the very end and just add normal maps at the end after we destroy Earth. Because once we destroy Earth, we have to go to Mars. So that might be the best time to do normal mapping. So maybe that's how I'll do. I just decided we're going to work on Earth. Once we're done with Earth and we destroy it, we're going to move on to Mars and we're going to learn normal mapping. Okay, so I see you guys in the next video, which should be about rim lighting, and I think I'm all out of time to record today. So I'll see you guys in the next video.